For 99% of human history, our species was constantly on the move. In 10,000 BC, the global population was roughly 2 million people, scattered in small nomadic bands, migrating endlessly just to survive the seasons. By 500 AD, the global population swelled to 209 million people, living within massive, interconnected empires. Multiplying a population 100 times in 10 millennia requires more than favorable weather. A spike this aggressive requires an artificial catalyst. This explosion followed a mechanical chain reaction. By solving the most basic problems of physical survival, early humans accidentally triggered the invention of modern civilization. To understand ancient history, we have to look past the individual battles and kings. We have to track the domino effect of human scaling. The first domino falls around 9000 BC in the Fertile Crescent. People living there shifted away from foraging and began the deliberate planting of seeds and the domestication of animals like sheep and goats. This shift created a caloric surplus. Because they could yield and store more energy from the land than they consumed, they were no longer forced to migrate with the seasons. They could stay in one place. Geographic anchoring caused population density to skyrocket. By the Uruk and early dynastic periods in Mesopotamia, thousands of people were living in permanent clusters. These were the world's first cities. Packing thousands of people into a static location permanently broke the old social structure. The egalitarian systems of small hunter-gatherer bands could not manage this volume of people, creating an immediate need for a new way to govern. The city introduced a massive existential threat: data management. Tracking the city's taxation, managing communal grain storage, and coordinating specialized labor divisions is a mathematical task that exceeds the capacity of the unassisted human brain. By 3400 BC, the Sumerians found a solution in this early cuneiform tablet. Notice the rigid, rectangular grid sections. It functioned as a hardcore accounting technology. These abstract hash marks stored the raw data necessary to prevent these dense cities from starving. This data problem was universal. As populations thickened across the globe, we see writing systems independently invented in Egypt, China, and Mesoamerica. By offloading human memory onto clay, bone, and stone, our ancestors crossed the threshold from prehistory into recorded history. Knowledge could finally stack and outlive its creator. Written records also solved the problem of physical scale. This is the Code of Hammurabi Stele. With dense text carved into the stone, a single ruler could project their authority and enforce laws over vast distances without needing to be physically present. Centralized law created a standardized rulebook. Once a city-state could effectively administer its own territory, it could absorb and manage its neighbors, giving rise to the first true empires. But sharing borders with other megastates triggered a military arms race. Holding expansive territory against rival empires demanded continuous upgrades in battlefield technology, heavily relying on the mechanics shown in this bas-relief carving. Around 1600 BC, the Hittites began casting iron in molds for stronger weapons and engineered light chariots utilizing the spoked wheel for unprecedented maneuverability. Codified law organized the population, while accelerated military technology protected them. Combined, they provided the engine necessary to build, expand, and maintain these megastates. By 500 BC, that engine produced the Achaemenid Persian Empire. Under leaders like Cyrus and Darius, it stretched from the Indus River to Egypt, the largest footprint the world had ever seen up to that point. Managing an empire of that size required the invention of federated systems of government and the construction of massive continental road networks to rapidly deploy both military troops and urgent messages across the empire. These stable mega-empires and road networks inadvertently created highly lucrative cross-border trade routes. The volume of wealth flowing between these states birthed a complex inter-empire economy. The seafaring Phoenicians positioned themselves as the middlemen of this trade. But doing business across dozens of distinct cultures required a faster way to communicate. As seen in these carved Phoenician characters, they invented a phonetic alphabet, a system of simple, linear characters that represented sound instead of complex ideas. The desire for imperial control and wealth inadvertently laid the groundwork for a shared communications network that linked distant empires across the Mediterranean and the Near East. By the close of late antiquity, around 500 AD, the borders of those ancient superstates were shifting and collapsing, but the human species had been permanently rewired. Over 5,000 years, humanity underwent a complete operating system update: the wheel, the phonetic alphabet, alloy metallurgy, centralized government, and written law. These systems provided the essential structural scaffolding for that hundredfold population increase. By scaling resource management through technology and law, humanity survived in densities that would have previously triggered mass starvation. The chain reaction that started in the ancient world locked humanity onto a track toward the modern era, pushing over dominoes that are still falling today.